Fine. Let's start. Tonight, if the sky is clear and you're somewhere away from the city lights, you can look up and find a faint smudge in the constellation Andromeda. No telescope needed, just your eyes. That smudge is a galaxy, 2.5 million light years away. The photons landing on your retina right now left that galaxy before our species existed. Before Homo sapiens. Before even our immediate ancestors. The light was already in transit while stone tools were being invented for the first time. And here's the thing. Andromeda is our neighbor. It's the closest large galaxy to us, the nearest thing to a cosmic next door. This list doesn't start with Andromeda. It ends with something so far away that the distance between you and that smudge in the sky will feel, by the time we're done, almost cozy. Number 10. Go outside on a clear night, somewhere dark, and find Andromeda. It takes patience. It looks like a soft smear of light, fainter than you'd expect for something 2.5 million light years away. But here's the detail that tends to stop people cold. That patch of light is physically larger in the sky than 6 full moons placed side by side. We just can't see most of it with the naked eye, because it's too dim. 6 moons wide, 2.5 million light years away. And the light crossing that distance to reach you does so silently, constantly, without asking anything of you in return. You just have to be outside and looking. That's the farthest thing a human being can see without any technology whatsoever. The absolute unaided limit of human vision is a galaxy, not a planet, not a star. A structure containing 1 trillion suns, most of them probably orbited by planets sitting 2.5 million light years away, and it's just there. Available. Every clear night, the universe left the door open and we mostly forget to look through it. Number 9. Until 2014, we thought we knew our cosmic address. The Milky Way, we said, is part of the Local Group, which sits inside the Virgo supercluster, a collection of galaxy clusters about 100 million light years across. That was the story. That was home. Then astronomer R. Brent Tully and his team did something clever. Instead of just mapping where galaxies are, they mapped how galaxies are moving. The subtle gravitational currents pulling them in different directions. And what they found was that the Virgo supercluster, our supposed home, is not a structure in its own right. It's a single lobe, a suburb, a room in a much, much bigger house. They called the bigger house Laniakea. It's Hawaiian for immense heaven. Laniakea spans 520 million light years. It contains roughly 100,000 galaxies. And the Milky Way sits on its outskirts near the boundary with another supercluster we're slowly drifting toward. We didn't know this until 2014. Not because the tools didn't exist, but because we were asking the wrong question. We were looking at positions when we should have been looking at motion. The name was suggested by a Hawaiian language professor to honor Polynesian navigators who crossed the Pacific using only the stars. There's something fitting about that. The people who once used the sky to find their way across an ocean, their descendants helping name the ocean itself. We live in the neighborhood of nowhere in particular, on the edge of an immense heaven we only just discovered we were inside. Number 8. On September 5th, 1977, NASA launched a spacecraft called Voyager 1. Its original mission was a flyby of Jupiter and Saturn. It did that. And then it just kept going. It is still going. In November of 2026, Voyager 1 will cross a milestone that no human object has ever reached, 1 full light day from Earth. That's the distance light itself, the fastest thing in the universe. Travels in 24 hours. Voyager will have taken almost 50 years to cover it. Right now, any signal sent to Voyager 1 takes nearly 24 hours to arrive. Any response takes another 24 hours to come back. Project manager Suzanne Dodd put it plainly, if you send Voyager a good morning message on Monday at 8 in the morning, you get the reply Wednesday morning at 8. A 2-day conversation with a machine traveling at 61,000 kilometers per hour. The nearest star system, Alpha Centauri, is 4.2 light years away. At Voyager's current speed, getting there would take over 75,000 years, and yet people sometimes describe Voyager as leaving the solar system. It did cross the heliopause, the boundary where the sun's charged particles give way to interstellar space. That happened in 2012. But the solar system, gravitationally speaking, extends out to the Oort cloud, and Voyager won't reach the inner edge of the Oort cloud for another 300 years. We sent a probe into space in 1977. It's been flying ever since. It carries a golden record with sounds of Earth, music, greetings in 55 languages, the sound of rain, a mother kissing a child. And in 300 years, it will reach the beginning of our own solar system's backyard. That golden record is out there right now in the dark and the cold, moving at 61,000 kilometers an hour. It's barely left the house. Number 7. The Oort cloud is one of the least discussed and most important things in astronomy. It's a vast spherical shell of icy objects, billions of them, maybe trillions, surrounding the solar system in every direction. Comets come from there. Long-period comets, the ones with orbital periods of thousands or millions of years, originate in the Oort cloud. Something nudges them, a passing star, the gravitational tide of the galaxy, and they begin a slow fall inward. The Oort cloud starts roughly 2,000 astronomical units from the Sun. 1 astronomical unit is the distance from Earth to the Sun. Pluto orbits at about 39 to 49 astronomical units. The Oort cloud starts at 2,000. Its outer edge extends somewhere between 100,000 and 200,000 astronomical units out, which works out to between 1.5 and 3.2 light years from the Sun. To put that in terms that actually land, the nearest star to our solar system is Proxima Centauri, 4.2 light years away. The outer edge of our solar system may extend more than halfway there, and we have never visited any of it. Voyager 1, the fastest and farthest spacecraft ever launched, won't reach the inner edge of the Oort cloud for another 300 years. Once it does, it will take another 30,000 years to pass through the other side. The Oort cloud doesn't emit light. We can't photograph it. Its existence is inferred entirely from the behavior of comets. We've never directly observed a single object in it. Almost the entire volume of our solar system is unexplored, unvisited, and invisible to us. And it's bound to our sun. It's ours. We just haven't been there. 30,000 years. That's how long it takes to cross our own backyard. Number 6. In the 1970s, astronomers started noticing something strange. Galaxies in our region of the universe weren't moving purely according to the expansion of space. There was something extra, a coherent drift, as if something enormous was pulling everything in the same direction. That direction, a point in space roughly 250 million light-years away, in the direction of the constellations Centaurus and Norma. The Milky Way, along with Andromeda, along with tens of thousands of other galaxies, is being pulled toward this point at around 600 kilometers per second. That's about 1.3 million miles per hour. It was named the Great Attractor, and for years, nobody could see it. Here's why. The Great Attractor sits almost directly behind the plane of the Milky Way. Our own galaxy's disk, its stars, gas clouds, and dust, occupies a strip of sky that astronomers call the zone of avoidance, because it obscures roughly a quarter of the observable universe in visible light. We were being pulled towards something, and our own galaxy was blocking the view. In 2016, a team using the Parkes Radio Telescope in Australia managed to pierce through the dust. Radio waves don't care about gas clouds. They found 883 previously unknown galaxies in that direction. A third of them had never been seen before by anyone. And what they found wasn't exactly a single massive object. It's more like a gravitational focal point, the center of the Laniakea supercluster we talked about in number 9. What we call the Great Attractor is, best we can tell, the gravitational center of our cosmic home, an address inside the address. But even Laniakea, we now know, appears to be falling towards something further still. The Shapley supercluster, 500 million light-years away. The cascade has no obvious bottom. We're falling towards something, which is falling towards something else. It's turtles all the way down, except the turtles are made of hundreds of thousands of galaxies. And nobody is standing at the top. Number 5. In 1981, astronomer Robert Kirshner and his team were doing something unglamorous, cataloging galaxy redshifts, building a map of the universe's large-scale structure, routine survey work, the kind of thing that produces results slowly and without drama. And then they found a hole. Not a hole in the data, a hole in the universe. A region of space in the constellation Boötes, roughly 330 million light-years across, that contained almost no galaxies. Where standard models predicted roughly 2,000, they found fewer than 60. A few decades of follow-up surveys have brought that number to about 60 confirmed galaxies. 2,000 expected, 60 found. It's called the Bootes Void. Astronomers also call it the Great Nothing. Both names are accurate. To understand the scale, if the Milky Way had been located at the center of the Bootes Void, humans would not have known other galaxies existed until the 1960s. Not because we lacked the technology, but because the edge of the void would have been beyond the reach of every telescope ever built before then. We would have assumed we were alone in a universe made of one galaxy. We might never have known otherwise. But here's the detail that doesn't get mentioned enough. The Bootes Void isn't just missing galaxies. It's missing dark matter halos. The invisible gravitational scaffolding that matter is supposed to cling to. That's absent too. This isn't just a region where stars didn't form. It's a region where the architecture for star formation was never laid down. No light, no movement. Just a sphere of nothing 330 million light-years across, sitting there in the dark, quietly violating our expectations of what the universe is supposed to look like. The leading theory is that the Bootes Void formed from smaller voids merging together over cosmic time, like soap bubbles coalescing. Which is technically satisfying and somehow doesn't make it feel any less strange. It's not an absence of something. It's just the void, uninterrupted for a third of a billion light-years in every direction. Number 4. Right now, without any telescope, without any special equipment, without even going outside, you are being bathed in the oldest light in the universe. It's called the Cosmic Microwave Background, or CMB. It's the afterglow of the Big Bang itself, or more precisely, the light released 380,000 years after the Big Bang, when the universe cooled enough for electrons and protons to combine into neutral atoms. Before that moment, the universe was an opaque plasma. Light couldn't travel freely. It was trapped, constantly scattering off charged particles. Then, 380,000 years in, the fog cleared. Photons escaped. They've been traveling ever since in every direction, filling the universe, cooling, stretching, redshifting down from visible light into microwaves over the course of 13.8 billion years. Those microwaves are hitting you right now. They pass through walls. They pass through your body. They're everywhere. But here's the thing about the source. That light came from matter that was, at the time, relatively close to where we are in the universe. But space has been expanding for 13.8 billion years since then. So the matter that emitted the CMB, the matter that was on the other side of that fog, is now about 46 billion light years away. In every direction. We are surrounded on all sides by a shell of ancient matter now 46 billion light years away, radiating the oldest detectable light in existence. The CMB is not a wall at the edge of space, it's the wall at the edge of time. Before it, the universe was opaque. There was no light to detect. No instrument at any wavelength will ever see further back than this. The CMB is the last chapter of the book. Everything before it is a blank page. And when astronomers actually mapped the CMB, the Planck satellite, the Atacama Cosmology Telescope, they found tiny temperature variations across that ancient shell. Not random. Structured. Those variations are the seeds of every galaxy, every star, every planet. Every atom in your body was shaped by patterns in a map of 380,000-year-old fog. The universe left its fingerprints on the oldest light it ever made, and we can read them. Number 3, in November of 2013, a team of American and Hungarian astronomers announced they had found something that, technically, shouldn't exist. Working with data from the Swift Gamma-Ray Burst mission, scientists Istvan Horváth, John Hakila, and Zsolt Bagoli noticed that gamma-ray bursts, the most powerful explosions in the universe, were clustering in a specific region of the sky at a specific redshift. Clustering far more than they should, statistically, if matter were distributed evenly at large scales. What the clustering implied was a structure, a superstructure, something enormous connecting all those gamma-ray bursts. They called it the Hercules Corona Borealis Great Wall, its estimated size roughly 10 billion light-years across. Updated analysis in 2025 by the same team suggested it may be as large as 15 billion light-years. The observable universe is about 93 billion light-years in diameter. This structure, if confirmed, would span roughly 1/10 of everything we can see, from end to end. Now, modern cosmology is built on something called the cosmological principle, the idea that the universe, at large enough scales, is homogeneous and smooth. Not identical everywhere, but roughly uniform. No region should look dramatically different from any other. Scientists have calculated that any structure larger than about 1.2 billion light-years would violate this principle. The Hercules Corona Borealis Great Wall would be 8 to 12 times that limit. Here's the honest version. This structure is contested. Some papers argue the clustering is a statistical artifact. But the original discovery team published a reanalysis in 2020 and another in 2025, arguing that the evidence only gets stronger as the dataset grows. The proposed European mission called Theseus, a next-generation gamma-ray telescope, would, if launched, provide enough data to settle the question definitively. Until then, we have a structure that is either the largest thing in the observable universe or a very compelling illusion. And the difference matters enormously, because if the Hercules Corona Borealis Great Wall is real, if the universe actually contains a coherent structure 10 to 15 billion light-years across, then the standard model of cosmology, the model we use to describe everything from the Big Bang to the fate of the universe, has a crack in its foundation. The name, incidentally, was not coined by any of the scientists who discovered it. 3 weeks after the announcement, a Filipino teenager named Jondrick Valdez read about it on Wikipedia and added the name. It stuck. Astronomers started using it. It ended up in the papers. A teenager named something that might break physics. There are worse legacies. Number 2. In 1998, 2 independent teams studying distant supernovae made a discovery so unsettling that they reportedly didn't want to publish it. They'd been measuring the brightness of Type 1a supernovae, stellar explosions that always produce roughly the same amount of light, making them useful as distance markers. The expectation was to find that the universe's expansion was slowing down, gravity pulling everything together, gradually decelerating the outward rush of the Big Bang. Instead, they found the opposite. The expansion was speeding up. The universe is not decelerating, it's accelerating. Something called dark energy, which is a polite way of saying we have absolutely no idea what it is pushing space apart at an increasing rate. Saul Perlmutter, Brian Schmidt, and Adam Rees shared the Nobel Prize for this in 2011. It's as confirmed as anything in modern physics, and here is what that means for distance. There is a boundary, the cosmic event horizon, sitting roughly 16 billion light-years away. Any galaxy beyond that point is receding from us faster than light can cross the gap. Not because the galaxies are moving through space particularly fast, because space itself between us and them is expanding faster than light can traverse it. Light they emit today will never reach us, not in a trillion years, not ever. Right now, approximately 94 to 97% of the 2 trillion observable galaxies are beyond that horizon. Already unreachable, not someday, not eventually, now. Before this video ends, more stars, in distant galaxies we can technically still observe, will slip past the horizon and vanish from our reachable universe permanently. But here's the detail that tends to stop people. The majority of the observable universe became unreachable before multicellular life evolved on Earth. This is not a recent development. It's not something humanity caused or accelerated. The cosmos began sealing itself off from us before we existed. And then consider the future. In the very far future, our 1 trillion years from now, 100 trillion, any civilization still around in the remnant of the Milky Way will look out and see only the galaxies of the local group. Perhaps 50 galaxies. That's all that will remain gravitationally bound to them. Everything else will have redshifted into permanent invisibility. Those future astronomers, if they exist, will see a small, sparse, quiet universe. They will have no way of knowing that their ancestors once looked out and saw 2 trillion galaxies in every direction. There will be no fossil of that fact, no echo, no signal. They will think they understand the universe. They will be wrong, and there will be no way to tell them. We exist in what may be the only window of cosmic time where the full scale of the universe is visible to anyone. Before long, Queer Alvarez on cosmic time scales, that window closes. and it doesn't reopen. Look up. We are in the best seat the universe will ever offer. Number 1. In 2025, the James Webb Space Telescope confirmed the most distant object humanity has ever observed. It's a galaxy designated MOM-Z14. The light we receive from it has been traveling for 13.53 billion years. We see the galaxy as it existed just 280 million years after the Big Bang, when the universe was roughly 2% of its current age. By the time that light reached JWST's mirrors, the galaxy itself had been carried by cosmic expansion to a distance of approximately 33.8 billion light-years. That is the farthest we have ever seen. The current edge of human observation. But it wasn't supposed to be there. When JWST began its deep observations, astronomers expected the very early universe to look raw, primitive, a sparse scattering of proto-galaxies barely formed, nothing complex. Instead, they found more than 100 well-developed galaxies from that era, about 100 times more than standard models predicted. Galaxies that looked structurally mature long before they should have had time to become mature. MOM-Z14 itself contains stars with unexpected levels of nitrogen, an element that, according to our models of stellar evolution, shouldn't have had time to accumulate in those quantities by that point in cosmic history. Lead researcher Rohan Naidu said it plainly. It looks nothing like what we predicted. This is not a minor discrepancy. This is the universe, at its most fundamental and ancient, failing to match the best theory we've built to describe it. Theorists are revising models of early star formation, early black hole growth, early galaxy assembly. The data from JWST is forcing a genuine reevaluation of what we thought we knew about the first few 100 million years of time. And yet, MOM-Z14 is only the record because we can detect it. It's not the edge of the universe. It's the edge of what we can currently see. Behind it, between MOM-Z14 and the CMB wall we talked about in number 4, there are almost certainly more galaxies. Older ones. We just can't resolve them yet. And behind the CMB wall, space continues. Our best models say the total universe, and not the observable part, the whole thing, extends vastly beyond what we can see. Some inflationary cosmology models suggest it's at least 250 times larger than our observable bubble. Some models say it's effectively infinite. We can't know, not because we lack clever enough instruments, but because the universe's expansion has placed that information permanently beyond our reach. The CMB is not just the oldest light, it's the edge of knowability. On the other side of it, reality continues, stars burn, galaxies form, and collide and die. All of it completely indifferent to whether we know it exists. The universe does not end at the edge of what we can see. We just stop being able to look. There's something specific about that, not quite grief, not quite wonder, somewhere between the two. We are a species that spent thousands of years assuming the stars were fixed lights on a dome. Then we found out the stars are suns. Then we found out our sun is one of 200 billion in a galaxy. Then we found out our galaxy is one of 2 trillion in an observable universe. Then we found out the observable universe is a bubble, finite and shrinking in the ways that matter, surrounded by a vastness we can confirm exists but can never examine. At every stage, the universe turned out to be larger, older, stranger, and more indifferent than we thought. And at every stage, we kept looking. MOM-Z14's light has been traveling for 13.53 billion years. It crossed the entire history of everything, arrived at our mirror, and told us the universe doesn't match our models. That's not a problem to solve, that's an invitation. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them. See you in the next one.